Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the structure. The molecule is a 1,3,5 trisubstituted cyclohexane trioxine, a cyclohexane ring bearing 3 R groups, all on wedge bonds, i.e., all on the same face, at alternating carbons, C1, C3, C5, and 3C is equal to N of oxine groups at the remaining alternating carbons, C2, C4, C6. The 3 lone pairs drawn on the nitrogen atoms emphasize their stereochemical significance. Step 2. Check for AC3 axis. Because the 3 R groups are all equivalent and disposed at 120 degrees intervals around the ring, C1, C3, C5, and the 3 oxine groups are likewise disposed at 120 degrees intervals, C2, C4, C6, rotation by 120 degrees about the axis perpendicular to the mean plane of the ring maps the molecule onto itself. Therefore, the molecule possesses AC3 axis of symmetry. Option B is correct. Step 3. Check for chirality. AC3 axis is a proper rotation axis, not an improper axis, SN. The presence of AC3 axis alone does not make a molecule achiral. For a molecule to be achiral, it must possess an improper symmetry element, a mirror plane sigma, an inversion center I, or an SN axis. This molecule has no mirror plane, the 3 R groups are all on the same face, so the top and bottom faces are different, no inversion center, and no S6 or other improper axis. Therefore, the molecule is chiral. Option A is correct. Step 4. Check optical activity. A chiral molecule that is not a racemic mixture is optically active, it rotates plane polarized light. Since the structure drawn represents a single stereoisomer, all R groups on the same face, all oxime geometries defined, the compound is optically active. Option C is correct. Step 5. Conclusion. Since options A, B, and C are all correct, option D, all of these is the answer. Therefore, the correct answer is D. Therefore, the correct answer is option D.